Okay, lesson 12, I have the outline up again to use as a reference. And we're starting with question 10. Use the information diagram and proof to answer the question. Given triangle ABC is an isosceles triangle with base segment BC. Segment AD bisects angle A. Prove that angle B is congruent to angle C. Okay, so we need to complete the proof by deciding if reason 9 is correct. If not, choose the statement that should replace it. Okay, I'm going to look first in the review theorems for an example that has a triangle with some that it has an angle that's bisected. So if I scan it, that's using a perpendicular bisector. And so we're going to, the perpendicular bisector has more information given than what we were given. We were just given that it a segment bisects an angle. So this one is not going to help with this. So let's just read through and see what we can decide. So triangle ABC is an isosceles triangle. Okay, given. What does that mean? That means that side length, since the base is BC, the sides that are going to be the same is AB and AC. So these two side lengths have the same. That's what an isosceles triangle means. So then AD is the bisector of angle A. That is also given. What does that mean? That means BAD, this angle, is congruent to CAD, this angle. That's what bisects means. It means it cuts the main angle in half. So then segment BD is congruent to segment CD. So that's saying right here, BD is congruent to CD, which to give the definition of a bisector. And then it says angle BDA as a right angle. And that's definition of perpendicular. Okay, so that's saying that angle BDA right there is 90 degrees. And then it also says angle CDA is a right angle right there. That's definition of perpendicular. And then angle BDA is congruent to angle CDA. Right angles are congruent. That's true because they both have 90 degree measures. And then they're saying AD is congruent to AD itself. AD is going to be congruent to itself right here. This segment, which is a reflexive property. And then triangle ABD is congruent to triangle ACD. And then that's the side angle side congruence postulate. So which side angle side are they talking about? They're talking about side AB its corresponding side is AC. So there's our side. Those are congruent. Our angle right here is congruent to this angle, CAD. And then the other side is AD. Since it's a side length in both of the triangles, it's congruent to itself. So there's our side, angle, side, and side, angle, side, congruence postulate. And then it says angle B is congruent to angle C. Corresponding parts of congruent triangles are congruent. So So then it's asking if our reason in number 9 is correct. And yes, because this angle's corresponding angle would be angle C. So the indicated reason is correct. Okay, question 9. Use the figure to answer the question. The design shows a flag case that is in the shape of a triangle with a height that is a perpendicular bisector to its base. What is AC? Okay, so the goal of this is to find this length AC. And now we know we have a height right here, AD, and it is a perpendicular bisector. What does that mean? First thing it means is it meets the base at a 90-degree angle, and it cuts the segment it meets in half. So segment BD is congruent to segment DC. So segment BD is 3, and DC is also 3. Now, how is that going to help us find the length of AC? Well, if we look, we have a side angle side. Now, it doesn't matter that we don't know the height of AD because it's one of our corresponding sides. It's congruent to itself. So we have a side, BD, its corresponding side is DC because they have the same length. So 3 and 3. The angle that's corresponding is our 90, the CDA right here is corresponding to BDA right here. So we have a side and an angle, and then the following side is AD, and it's the same side in both of the triangles. So we have side angle side congruence. That means corresponding parts are going to be congruent to themselves. So BA's corresponding side is AC, and that distance is 4.24. So our answer is 4.24. Okay, use the following information to complete the proof. Given AD is the perpendicular bisector of BC, segment BC. Prove that segment AB is congruent to segment AC. Alright, and so if we wanted this is similar using the perpendicular bisector, so we can use this as a reference. We're going to have to decipher some of this because it's not the exact same setup, because the example is using angles and they want us to prove side lengths, but we can use it as a reference. So what is the correct reason for statement 8? That's what we want to know. So AD is perpendicular bisector of BC. That's given. That means segment BD is congruent to segment DC. BD is congruent to DC. That's our definition of perpendicular bisector. That also means that the measure of angle BDA, this angle, is 90. And the measure of angle CDA is 90. Definition of perpendicular bisector and definition of perpendicular bisector. Okay, then they say measure of angle BDA equals the measure of angle CDA. BDA equals CDA. Transitive property, and that's because they are both equal to 90 degrees right there. And then we can state that these two angles are congruent. Definition of congruent angles. And then side AD is congruent to side length AD. It's congruent to itself. It's the reflexive property. And then they want to know triangle A. They're stating triangle ABD is congruent to triangle ACD. Why? Why can we state that? What did we make? Did we have a side, side, side? Did we use side, angle, side? Or did we use angle, side, angle? And right now, we have a side with its corresponding part, the other, corresponding side in the other triangle. We have the 90-degree angles, and then we have the last side. So we have the side angle side congruent postulate. Okay, use the figures to answer the question. Line A intersects lines B and C at point A. Points G, A, and H are on line A. Points J, A, L, and K are on line B. Angle JAG is a right angle. Okay, I'm going to mark that. Angle JAG, right here, is a right angle. Point M is in the interior of angle JAG because it's between the two ending lines. Line L M is constructed through points L and M such that LM intersects line B, right here, line B, at point L. Given that AJ is congruent to AK, which figure is a perpendicular bisector of JK? Okay, AJ, where is that? Right here. AJ congruent to AK, right here. And we're talking about between JK. So we're talking about this line right here, JK. So which line cuts JK in half and creates a 90-degree angle? And that would be line A, right here. We were given that JAG created a 90-degree angle. So there's our 90 degree. We were also given that AJ and AK were congruent. So line A creates a perpendicular bisector to JK. Okay. This is the same information that was given in question 7. Very similar. So line A intersects line B at point P, right here. Points J, P, L, and K are on line B. Points G, P, H are on line A. Line C also intersects line A and B at point P, but shares no other points with either lines. On vector LM, M is on the interior of the angle GPJ, which is a right angle, which was marked. It is given that J to P is congruent from P to K. So we know from J to P, this distance is congruent from P to K. Which of the geometric figures pictured is not a perpendicular bisector of JK? Okay, well JK is this whole distance. And the one that cuts it in half and creates a 90 degree is line A. So the information is what other lines or figures is not line A. So we have line C. We have segment GH. Segment GH is on line A, so it is a perpendicular bisector. Vector LM is not a perpendicular bisector, and segment JK cannot be perpendicular to itself. So there's that. Okay, so before we move on, I'm going to give you another piece of advice. This is based off of Marissa Peer's work as well on ways to avoid what we would form as rejection. So the first one was saying, thank you for sharing that. And the second one is if they just keep at it, they just keep drilling you. And so, for example, say you had to give a presentation and one of your classmates said, that was horrible. You should never have given that report. Da 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 da. And they just keep writing you, and you say, thank you for sharing that. And they keep going, and you say, will you please repeat that slowly because I didn't hear exactly what you said. And when you reverse it and ask them to repeat what they have to say again, it's giving them a chance to reflect back on what they said and was it appropriate or needed. And the majority of the time, they will say, oh, never mind, what I said wasn't important, never mind. And so then you can just say, thank you for sharing that. And the next step, if they keep going, is, I'm sorry, would you please repeat that slowly? So there's the first two steps from Marissa Peer on how to avoid rejection. And then we're going to keep going, and I'm going to do one more example. Question 5. Use the following information to complete the proof. Given segment AB is congruent to segment AC, D is the midpoint of BC. Prove that A is on the perpendicular bisector of segment BC. Okay, now the question is asking what is the correct reason for statement 7. So let's read through what they have set up in the statements and the reasons so far, so we have an idea of where this proof is headed. So AB is congruent to AC. That was given. D is the midpoint of BC. That was also given. That means that segment BD and segment DC is congruent. That's the definition of the midpoint. Then they stated that AD is congruent to itself by the transitive property. Then we're saying that we have two triangles that are congruent. Triangle ABD is congruent to triangle ACD by the side-side-side congruence postulate, which is correct. Segment AB's corresponding part is AC, and segment BD, B to D's corresponding part is C to D, and then AD is the corresponding parts to each other. And then it stated angle BDA. So what angle is that? BDA, right here, is congruent to angle CDA. Alright, and by corresponding parts of congruent triangles are congruent. And then they're stating that the measure of angle BDA plus the measure of angle CDA equals 180 degrees. Why? Why can they state that? And if we look, these two angles, BDA and CDA, if you were to look at this angle, side BC, notice if I started with one side of angle BDA and drew all the way to the other side of angle CDA, I could make the straight line BC. So that is a good indicator that it is a definition of a linear pair because they make a straight line, and a straight line has 180 degrees. So then it follows through with the rest of the proof as to why. So the reason why we can make this statement BDA and CDA is equal to 180 degrees is because they form a straight line